Hello, I'm Rachel Park. In this episode of the MTC3 interview series, I will be talking to Chris Schuppe from GE Additive. Hi Chris, thanks for joining me.
Hi Rachel.
So I wonder if we could just start with you giving us a little bit of background into your experience with additive manufacturing.
Sure, yeah, I'd be happy to. I actually started working in 3D printing back in my university days in the polymer side.
Wow, okay.
And then I did a little bit of it when I worked at Toyota, but then really I started getting more into the metal additive side back in the mid-2000s. We actually worked with a company that we ultimately acquired, which was Morris Technologies.
Oh, wow. Okay.
So Greg's team was printing some additive parts for an engine program that I worked on, and I was just amazed.
That engine nozzle?
Actually, it wasn't the LEAP engine at that time.
Wow,
It was a test-only part that we were doing for another engine program, and I had the opportunity to work with Greg's team, and I was just amazed at the ability to go from a CAD model to a three-dimensional part in days.
He was absolutely a pioneer in this field.
Oh, absolutely,
wasn't he?
yeah, legend, and then that kind of led us to where we ended up in GE Additive. So. And then, from my personal perspective, I started working heavily both on the polymer and metal additive side inside of GE Aviation, and led GE Aviation's additive engineering team from about 2011 through to the acquisition and creation of GE Additive. So a lot of the applications, LEAP fuel nozzle, a lot of the GE 9X parts that GE Aviation released about 3-4 months ago. There's 7 parts on that GE 9X engine, 304 parts total. And then our GE Catalyst engine as well kind of grew out of that original additive team in GE Aviation. So.
Fantastic. Looking at GE Additive as an entity and the sort of larger parent company as well, it's a huge company that have taken additive manufacturing very, very seriously, but they've done it by obviously their own R&D development work with it, but also through acquisitions, and they use the technology, they provide the technology, they supply the technology. From a sort of 6-mile high view of the company, can you just sort of give us some idea of how all those pieces fit together?
Sure. So GE Additive at a very high level, we do machines, we do materials in the sense of the powders, and then we also do applications, so machines, materials, and applications. A lot of our GE expertise was on the application and materials side. So to create a first flying certified part in the FAA's eyes, a lot of that expertise was on the how do you turn solidified powder into metal that's predictable, repeatable, and robust enough for aviation applications. So we brought kind of the
validation process.
The validation and application side, including the materials. And really, when we acquired, RCAM and Concept Laser, that brought us the machine side as well. And then coupled with RCAM was AP&C, which actually produces the powder. So you kind of bring together that three tiers of application, materials in the sense of everything from the powder through to the solidified metal, and then the actual machine side. From a RCAM and Concept Laser perspective.
Brilliant. So coming to a more specific view of the company then, can you maybe enlighten us a little on the purpose and the vision of GE Additive?
Yeah, I think what GE Aviation felt when we were going through that process was the industry wasn't moving fast enough for what really aviation wanted to do in terms of industrial application of the technology. And then I think as we looked beyond just GE Aviation into the other GE businesses, we saw a lot of use cases as well, that they were just waiting for that sort of injection of more repeatable machines, better reliability, more robust qualification process, all the things you've heard about probably in the show this week were really reasons why we got into that industry. I think as GE's over the last 2.5 years since we formed the company really tried to focus on those core values of improving machines, improving reliability, but in the end it's about the application and the end use of the part. The machine in the end is a tool to make a part.
Absolutely.
The part is really where the magic happens, and how do we, with our heavy, user experience background, how do we help customers through that journey? We heard a lot in the show this week that customers are struggling and getting through that journey of additive. And so part of our team now is an application engineering team called AdWorks, which we go to customers and actually physically help them pick the best parts or systems, and we start kind of at the system level and work our way down, and then take those parts from basic idea through the business case into validation.
So as you've already mentioned, your background is predominantly within the aerospace sector. Could you just provide some insight into the challenges of developing critical applications with additive manufacturing, and maybe also some of the highlights?
Specific to aerospace?
Yes, yeah. That's what you're...
So I think if I've heard it once, I've heard it 1,000 times in aerospace. What are my material properties? And
right.
That's a very common place where historically aerospace engineers are taught to start with what material are you picking for that application and what are your material capabilities. And that's sort of where you start typically. Additive wants to change that mindset where you really start with what's the function of that part, and then kind of work your way into what material properties do I need to satisfy that, and then engineering the additive process to develop the consistency, that first of all the level of material properties, but then also with the variation that you see in the process, how do I meet that sort of min capability requirement that I need for the application. I think the ability to characterize materials and really scale that process and also work collectively with the regulatory agencies to help them understand. It's new for them too, right?
Yeah.
They're new consumers of the technology from a regulatory standpoint. So part of our work in aviation was frankly educating the regulators
producing
on
the data, I guess, as well.
How do you characterize the process? What are the critical control points? How do you make sure that the machine's working the same every time? A lot of those things went into what GE Aviation was able to accomplish in the 3D printing space, and I think now we're trying to help scale that for our other customers as well.
On that point, so looking outwards from GE Additive, how do external partnerships feature in your mission?
Very heavily, right? We're working very closely with many companies. I can't name them all, of course. But one of the things we found when we got into, most of our team came from an aerospace background. One of the things we found when we got into this space and started talking to automotive companies, as an example, that laser powder bed as it existed out of the box wasn't going to be cost competitive enough for them. So binder jet is an area where we're working today, binder jet additive manufacturing.
Metal
binder jet, yes, correct. And we've intentionally picked two partners to start we developed beta machines, and we're working collaboratively with them so that it's public information, Cummins and Wabtec. And they're helping us industrialize for industries that maybe we're not experts in, but we understand the physics and the chemistry of the binder process. They're bringing sort of that industry expertise of what does it take to be successful at high volume manufacturing. So that's one example where we're doing that.
So one of the latest partnerships that's been published is the Caspar Schultz brewery application.
Yeah.
Is there any insights you can give us there, or is that too far out of your remit?
No, I definitely can talk about that one.
Okay.
I mean, and I think, coming from an automotive and aerospace background, I never thought I'd be working in the brewing industry.
It sort of leads on from what you were saying.
Yeah, I'm good at drinking beer. I'm not sure I'm good at making it. But,
we all?
but I think this was a case where a local company in Bamberg that we have a lot of employees that sit in Bamberg, so we developed a relationship with them. We worked with them to find, in their process, basically a mixing application where we could use additive manufacturing to create better overall performance of their brewing process. And if we would have just said, "Hey, we're going to print the parts that you make today," it's not really that impactful for them. But if we could print a part that would make their brewing process that much more efficient, that's where you start to win. So again, that goes back to that application and how do you make sure you're finding the right business case and utilizing the shape freedom and additive to enable new performance that isn't possible with conventional manufacturing. And by the way, if you can brew a great beer at the same time, that's fantastic.
Well, I think on that note, we should probably wrap up. So Thank you very much for your time today.
Thank you very much. I appreciate it.